So hello, I'm Anurag. So today we are going to see how the DFS algorithm of a graph work. Like how can we traverse the graph using DFS algorithm. So let's begin with it. So firstly we have search question where it is DFS of graph and DFS of graph and GFG. It's appear at the first option. So here is question. So in this question we have given a adjacency list. So let's copy this adjacency list and put it in Excel draw. And now I will try to construct the graph from it, like how our graph become. So we can see that here it is given a 2D array. On the zeroth index there is second 231, like it's donating the nodes that is connected from the zero. So we begin to construct the graph. So this is the zeroth node and it is connected to the second node, it is connected to the third node, it is connected to the one node, first node. And then we go uh, ahead, we see the first node is connected from one node, like it is an undirected graph, means there is a edge, both edge that is from the both side. Like we can also write like this and this, the edge is in both direction, it simply means. So when we go to the next, the second node is connected to the fourth node. And when we go ahead, we can see that the third node is connected to zero, it's already done. And at last the fourth node is connected to the second node. So we have the graph. So now we look how to traverse it using DFS algorithm. So in DFS algorithm, we use the concept of recursion, like how we go to the depth and at some condition we terminate the search. So let's start the DFS algorithm. So for this, let's in the question it is given that we have to start from the zeroth node. So let's begin our traversal from the zeroth node. So basically in this algorithm we have to make a visited array. Like suppose if there is any, so we have to make a visited array to avoid getting stuck in the loop. Like we, what if we start visiting the visited node again, so we have to mark that okay, this node is visited. So for this we have to construct a visited array. So the size of visited array is of the number of nodes that is given in the graph. So here we can say that where we have 1 2 3 4 5 nodes, so the size of the visited array will be 5. 1 1 2 3 4 and 5. So we have to start from the zeroth node. So we have to start from the zeroth node. So we mark it visited in the visited array. Like we make one at the zeroth index. So we starts our algorithm from the zeroth node. So DFS algorithm start. So we call the function DFS, passing the starting node and the visited array. So in this algorithm, what happens? The search goes to this, the search go to the depth first. Then after not getting anything, it returns back to the parents. Like in the way I am making, like this is the longest depth. After covering the deepest point, it again came back to the parents and again start exploring the further children's. Like the way I am making in the picture, you can see that after coming from the fourth, it go to 2, then 0, and then to its remaining children's like 3 and 4th. So when I try to write the traversal, So let's go to the flow of arrows and write the traversal. So firstly we have 0, then 2, then 4, then we came back to 0 and then gone to 3. Here at the 3 it has no any children. So we don't go to the we don't go to the deep, and again came back to the 0 and then go to the last remaining children. So that is one. And in doing all this we keep marking the nodes which is visited. Like when we go to the second, we will mark it as visited, and when we go to the fourth, we mark it as visited. Then we came back and again go to the third, and so mark it visited. And when from three, when we came back to here and then go to one, so we mark it visited. We are doing this in case of not going to the visited node again. So this is the DFS algorithm. So the time complexity of a DFS algorithm is also V plus E, O of V plus E. Like we are going to the every vertices and exploring all its edges, all its nodes. And the space complexity will be O of N for the visited array, and also there is a recursion, a stack space. Like we all know, in recursion it takes a stack space of calling the functions. So let's try run this example. This here are the 0 is connected from 2 3 1, 2 3 1, and 1 is connected to 0, 2 is connected to 4, 2 is connected to 0 and 4, 2 is connected to 0 and 4, and 3 is connected to 0, and the fourth is connected to 2. So let's draw all the function calls. So for the first time, the DFS will be called from the 0th node with the visited array. Then we go from here to here. So the next call will be from the to second node. Now it will come here, and DFS is called from here. Like why I created the visited array, so that when it came to this place, it's not go to the visited node again. So as I gone to the first node, so I mark it as visited, so it don't stuck in a loop. So it will not go to 0th node and will go to the fourth node. So here we write the fourth node and again call the function. So it will go to the fourth node, and here we can see that the second node is already visited. We have marked it in the visited array. So it will not go to the second node. And you can see that there is no further child of the 0th node. So it simply the came back to the place where it came from, and 0th. And then the third second children of the 0th node is visited. We will go to the third node and write DFS of 3 with the passing the wasted array to chat. And then when we go to the third node, we can see that the 0th node is already wasted. So we will came back from the here, and at last we will go to the first node. And for the first node, we call the DFS and mark it as wasted in the array and call it. So when it go to the first node, we can say that 0 is already wasted. So it will return from the here, and our DFS algorithm gets completed. Like all this function is uh, all this function will disappear from the stack recursion stack space after the traversal is completed. So we will get the traversal as we want.